Today we're going to talk about energy metabolism and metabolic adaptations to training. First, we're going to talk about aerobic versus anaerobic metabolism. Aerobic metabolism is the production of ATP with oxygen, while anaerobic metabolism is the production of ATP without oxygen. Here are some characteristics of enzymes. They speed up or catalyze a reaction. They convert reactants at a rate necessary to meet the activity demands. They do not change the result of the reaction, and they are not changed when they catalyze a reaction. First, we're going to talk about aerobic ATP production, and this happens in the ATP-PC cycle or anaerobic glycolysis. And these two metabolic systems are usually used when you're training or your exercise goes from anywhere from under 30 seconds to about a minute and a half. This here is what the cycle of anaerobic glycolysis looks like. You have muscle glycogen here, then it is catalyzed by the phosphorylase into glucose 6-phosphate, which is also has blood glucose, which has been catalyzed by hexokinase. And as you can see here, there's ATP and ADP produced. Then another enzyme, glucose phosphate isomerase, into fructose 6-phosphate, while producing another ATP and ADP. Phosphofructokinase produces fructose 1,6-bisphosphate. And then adolase, the enzyme right here, catalyzes it into dihydroxyetone phosphate, and it has two of them. Then triose phosphate isomerase catalyzes it to 2-glyceraldehyde 3-phosphate. And then the glyceraldehyde 3-phosphate dehydrogenase, that's an enzyme, catalyzes it to 2,1,3-bisphosphate bisphosphogylucerate. And as the enzyme phosphoglycerate kinase produces 2 ADP and 2 ATP, it also catalyzes to 3-phosphoglycerate, while another phosphoglycerate mutase down here turns into 2-phosphoglycerate, with the enzyme enolase catalyzes it to phospholinol pyruvate. And as you can see here, there's another 2 ADP and 2 ATP produced. And then after this, the enzyme pyruvate kinase catalyzes it to pyruvate. And then the byproduct of pyruvate here, as you can see, is lactate. And then after you've been doing your exercise or your training for more than a minute and a half, roughly, your body is going to take that pyruvate and switch to the aerobic metabolic system, or the Krebs cycle. So as you see here, you have your pyruvate from above, from the anaerobic metabolic cycle. It is then moved this way with a byproduct of CO2, while adding amino acids and fatty acids for beta oxidation. You get acetyl coenzyme A. Then it is moved down to citrate. Then with another enzyme, aconitase, is then moved to cis-aconitate. With the same enzyme, aconitase, it is then moved to isocitrate. Then with the enzyme isocitrate dehydrogenase, you have a byproduct of CO2 while producing some ions right here. Then it is moved to alpha ketoglutarate. Then with another enzyme, alpha ketoglutarate dehydrogenase, you have a byproduct of CO2 and more ions that we're seeing right here. then you can either, it is then basically catalyzed into succinyl coenzyme A, then catalyze succinyl coenzyme A synthetase with a byproduct of ADP and ATP. Then succinate is catalyzed in bisuccinate dehydrogenase with another byproduct here into fumarate. Fumarase, the enzyme, catalyzes this into malate with a byproduct, and then with malate dehydrogenase, you have a byproduct of an ion, and you're back up to oxaloacetate. And as you can see, you have other factors over here. Amino acids it's all just one big cycle. Everything is cycled back together. Pyruvate to this, and it all circles back around. Here is the inverse relationship between power and capacity. As you can see here in the first two systems, ATP system and anaerobic glycolysis, you have more power but less capacity. And as you go farther down the scale, you're going to have less power on the scale, but you're going to have a longer capacity and a larger capacity. Some metabolic adaptations to training are, depending on the sport you play, your adaptations are specific to your training. So for sprint training, it increases in cellular concentrations of key aerobic enzymes, and this can improve your sprinting performance. It also increases the phosphocreatine stores in the muscle, so you can maintain a high intensity exercise for a longer period of time before you fatigue or get tired. Some adaptations for resistance training. It's an increase in strength and size of the exercise muscle while increasing the force production capabilities as well. Also, the metabolic effects are specific to the type of program.